Okay, now that we know the optimal objective, we need to determine the optimum solution. How do we determine the optimum solution? Well, we move now from right to left, from New York to Los Angeles. And the way we're going to do this is imagine we've done all the calculations and we get to the beginning. We already did this. And we had something like an arrow going here. So we know what the first action is, what the first optimal action is. So the way this works is, since you know what the first optimal action is, you use the transition relationship to find out where you're going to end up. You know where you are, you know what you should do, and therefore through the recurrence, through the transition relationship, you're going to be able to determine where you're going to end up, what city you're going to end up in this example. And once you know that, you know the next stage, you can look up the arrow that you decided to take at that. And this is stage 1, and this is stage 2. You know what to do here. You know this is going to end up here. That's where you end up. Then you can look up what the arrow goes next. And you keep on doing this, and now you know where you're going to end up in the third city. And then you can look up again. You can look up again the optimal action to do there. This goes on ad nauseum until at the end you know where you're going to end up. And of course, if there's any choices to be made there, which there aren't in this case, you will know what to do when you get to Los Angeles. And that determines the optimum solution. The next thing to do is to take this general abstract framework, I hope to make it a little bit more concrete through using the map, and apply it to an inventory problem.